right, so in this problem, we're going to go over how we can find the distance between two parallel lines. So right away, you want to just make a sketch, a picture of what's going on. It doesn't have to be perfect, but it definitely has to show that these lines are going in the same direction and some other key things that'll help you. So what I would do is, draw an axis of something like that, and I know they're going to be going diagonally, like, in this direction since their slopes are negative. And the y-intercepts are both negative, -2 and -4. So maybe I'll just draw the x-axis up here because I probably won't need any points up here. They won't be that important. And then let's use my engineering tools to draw two parallel lines. So let's say y1, looking something like that. Maybe we can go a little further. Maybe even further. Here I have y1 being equal to -3x minus 2. And the thing about this, I can tell right away that since they're sloped, kind of steeply or more steep than you're probably used to, they're going to kind of appear to be close to each other, and then that may make it seem like the distance is like complicated to like figure out. So just don't do that. Just put them far away. Put a point over here for the other line. Just give yourself some more space to work. I think that'll be all right. And writing that this is going to be y2 with the equation -3x minus 4. And let's highlight the key points it goes through. So it goes through this point because the y-intercept, is -4. Well, I didn't write the numbers yet, but it's going to go through the point 0, -4 because that's the y-intercept. This one's going to go through the point 0, -2. Not drawn to scale, as you can tell. So don't make the mistake, because students will do this a lot. I get very sad and I cry when I see this on a test. Don't just draw this line to that line. Like that's not correct. It's not, that wouldn't, that wouldn't even be a math problem. Like what we want to do is pick a point. You can pick this point or pick this point, but from there you have to generate another line that's going to be perpendicular to the other line, or to each line technically, because since they're both, sloped the same. So let's just go with this guy over here. Let's choose have a different color. Let's pick blue. I'm going to make a perpendicular line going through there. The third line, y3 is joined. So I'm going to call this guy y3. Now y3 is perpendicular to y2, and of course it's going to be perpendicular to y1 because they're both, they both have the same slope. So let's label this point. Let's just call it, I don't know, let's call it Q, point Q. And we need to find out how far point Q is from this point. Let's call this point T. So we need to figure out where point T is. Once we figure out where point T is, then we can, just use the distance formula. We could, we just plug and chug the coordinates to the distance formula, and it'll be easy work. Okay, so how do we find y3? Well, we have to basically start off by making the slope the opposite reciprocal of -3. So the slope is -3, so think about what the opposite reciprocal is, because that's if you don't get this one right, your line is not going to be correct. So all we do is flip this and change the sign. So the slope of y3 will be 1/3. When we go y3 equals 1/3 x plus b. And we have to find the y-intercept of this. I'm switching my marker. And what do you know? Like if you caught this, see why I picked this point is because the y-intercept is already solved. So see how smart I am? That's what you want to do when you're working on these problems. You want to be efficient. So it goes through the point 0, -4. You can plug -4 and 0 and get it again, but then we know then that the equation for y3 is 1/3 x minus 4. Now we find where point T is, and that's going to be by setting y3 equal to y1, because that's where they cross. So let's go and have y3 equal to y1. So have this for y3. y1, we have -3x minus 2. And this is the fun part. You don't mess up because the fraction is there. So you gotta be on top of your fraction game. So let's bring the x's to the left, and let me keep them separated at first, just so we can work it through step by step. So 3x plus 1/3 x on the left. Let's add that 4 to that -2. So we have 3 and 1/3 x. 3 is the same as 9/3 x. So we just have 9/3 x plus 1/3 x, and then we'll get 10/3 x. Well, let me make that a little better. Oh, 10/3 x is going to be +2. And then make sure you know, again, your math. Get rid of this 10/3 by multiplying by the reciprocal. Just flip it 3/10 both sides. These cancel, and we get x is going to be 6/10, or if we can reduce right away and get 3/5. So then at point T, the x coordinate is 3/5. Now we have to find the y coordinate. We can find the y coordinate by plugging this 3/5 in into either y3 or y1, because that's where they both cross. Doesn't matter which one, just make sure you do one of them and do it correctly. And let's see what we got. Which one is probably going to be less work? I'm not really going to. Oh, y3 probably, because that 3 and that 1/3 is going to probably make our lives a little less messy. So let's go and work it out over here. So plug it in 3/5. Let's go like this. Into y3. So just coming down, we'll go y3 equals 1/3 times 3/5 minus 4. 3's cancel. I don't know why I switched to blue, but okay. Let me switch back to black. So y3. We don't have to call it y3. We can just call it y, but I'm just going to keep the 3 there because I like it. So then this is going to be then 1/5 minus 4. Okay, so more fractions. Cool. So we'll call it y3. 1/5 minus 4. 4 as a fraction is just 20/5. So it's 1/5 minus 20/5. So y3 is -19/5. And so this is going to be at the coordinates 3/5 comma -19/5. All right, so now what? Now we just plug these points into the distance formula and plug these points into the distance formula. Let's just have this be x1, y1, x2, y2 doesn't matter. I don't even know why I need to write it, but just in case you need it. If you remember the distance formula, let me see if I can work it up. You can work it out over here. So we're going to have qt be equal to the square root of x2 minus x1, or 3/5 minus 0, squared, plus y2 minus y1, so negative 19 fifths minus a negative 4. All that is squared. Erase that down. Let me switch to red. And let's just keep on working it. So 3/5 squared, that'll be 3/5 times 3/5, so 9/25. Plus, this will be negative 19 plus 4. So this 4 becomes just a 20 over 5. So it becomes negative 19/5 plus 20 over 5. So it becomes just 1/5. And then so we just have 1/5 squared there. So 9/25 plus 1/25, because 1/5 times 1/5 is just 1 over 25. And then we just got 10 over 25 as underneath there. The square root of 10 over 25. And that's, we're gonna get some cool decimal. We can reduce that into like 2 over 5, square root of 2 over 5. Square root of, let's see what we get. So we have the square root of 0.4, and then, which is going to be approximately 0.63 0.63245 units. And that makes sense because they're going to be really close together. And yeah, well, there you go. So again, with these problems, just make sure you write clearly, show your work, show the steps. Then you find that's not only easy, but it's also fun. All right. I'll see you guys in the next video.